Okay, example 3, again, we are trying to find a more complicated looking area. The reason this area is more complicated is because it's enclosed by more than two curves. Again, remember, I use the word curve loosely. It can also mean a horizontal line or a diagonal line. So this area here is clearly enclosed by a diagonal line. There's one curve. An actual curve, there's two curves. And a horizontal line, there's three curves. So it's enclosed by more than two curves, so we can't get its area directly. We're going to have to break it up in some way. Now, this area is quite difficult to break up, but what you could do is, if we go to this point 1, 2, and we draw a vertical line down from that point to the x-axis, and then we drew another horizontal line across the x-axis from that point to where this line here hits the x-axis, we have a right angled triangle. Now, the plan would be we could get the shaded area by getting the area of the right angled triangle, getting this little area in here, and then doing a subtraction. So is it possible to do that? Well, let's start by getting the area of the big triangle. So because the x-coordinate of this point is 1, then the x-coordinate of this point down here is also going to be 1. So we know what the base is. We also know what the height is because the y-coordinate of this point is 2. So the height is clearly going to be 2. So let's start with the big triangle. Area of big triangle. So area A equals a half BH. So that's a half times, base is the difference between 1 and 3, so that's just 2. And then the perpendicular height here is just 2. So half times 2 is just 1, 1 times 2 is 2. So the big triangle contains an area of 2 square units. Okay, what I'm going to do now is I am going to label this little bit inside the right angle triangle that isn't shaded. I'm going to call that A1. Now, is it possible to get A1? So A1 is bounded by a curve. This curve's clearly on the top. And then the horizontal line y equals 0, or the x-axis, is on the bottom. So it's only bounded by two curves. So we can actually integrate to get A1, which is great news. So we know what the top and bottom is. We also know the limits. So we know that this area lies between 1 and 2 in the x-axis. So let's now work out A1. So we'll write down our formula. So to integrate to get an area A, that's equal to the integral of A and B. Those are the limits, in other words the values of x that the area lies between in the x-axis. And then it's top subtract bottom. With respect to x. So let's sub in all the information. So to get A1, we're integrating between 1 and 2. So the bottom limit is 1, top limit is 2. Open brackets. Now the top, so which curve is above this area A1? Well, it's clearly the actual curve, which is this, y equals 2 plus x minus x squared. So we're subbing in the non-y terms, 2 plus x minus x squared. So 2 plus x minus x squared, and then we're subtracting. So the bottom here, so what is directly underneath the area A1? It's the x-axis, and it has the equation y equals 0. So we're subbing in the non-y term there, which is 0. And then we're integrating with respect to x. So tidy it up, get rid of brackets. So we're integrating between 1 and 2 of 2 plus x minus x squared. So we're now ready to integrate, and because there's limits, we put square brackets down. So integrate, we're going to get 2x add 1 to the power, divide by the new power. So we're going to have plus x squared over 2. Add 1 to the power, divide by the new power. So we've got minus x cubed over 3. And don't forget to add the constant, plus c. And then we copy the limits down outside. So same as before, we're going to break up this single bracket into 2 separate brackets with a minus between them. So we're going to sub the top limit here, the bigger limit, into the integrated expression in the first square bracket here. So replace x with 2. So we've got 2 upon 2 plus 2 squared over 2 minus 2 cubed over 3 plus c. Again, in the second square bracket here, we're going to sub the bottom limit, or the smaller limit, into the integrated expression. So we've got 2 times 1 plus 1 squared over 2 minus 1 cubed over 3 plus c. So tidy up each bracket. So the first one, we've got 4. We've got 4 over 2 is just plus 2. Minus 8 over 3 plus c. And then we're subtracting. We've got 2 plus a half minus a third plus c. Okay, we can use our calculator then to tidy up each bracket into a single numerical value. So we've got 4 plus 2 minus 8 over 3. So that's going to give us 10 over 3 plus c. Copy down our minus and then tidy up our second square bracket. So we've got 2 plus a half and we're subtracting a third. So that's going to leave us with 13 over 6 plus c. So the c's cancel out. So we're left with 10 over 3 minus 13 over 6. And that's going to leave us with 7 over 6 units squared. Okay, I should actually have put units squared up here. We worked out the area of the big triangle. So we're now going to get the shaded area. Or the overall area. Now we're not adding this time. To get the shaded area, we're taking the area of the triangle and we're subtracting A1. Okay, so shaded area is going to be area of triangle subtract A1. And the other examples, we were always adding the separate areas, but here's a nice little example where you're not, you're subtracting. So area of triangle, remember, was 2, and we're subtracting 7 over 6. So our final answer, 2 subtract 1 and 1/6, you're going to be left with 5/6 square units. And that's it.